Okay, this is the third video for Chapter 8, and in this video we're going to talk about estimating population proportions using confidence intervals. In the first two videos we looked at estimating population means, but we also need a way to estimate population proportions. The requirements for this look a lot like the requirements for estimating population means. First of all, the sample has to be a simple random sample, but here we have to have the conditions for a binomial distribution satisfied. So there has to be a fixed number of trials, the trials have to be independent, there have to be only two categories of outcomes, and the probabilities have to remain constant for each trial. A third requirement is that there have to be at least 5 successes and 5 failures in our sample data. Here's the notation. The only thing that's different here is that we use p-bar, which is the sample proportion. And we do have to put this in decimal form to use it in the formulas. And we get our sample proportion by taking the number of successes in the sample data and dividing by the sample size. Our formula for the margin of error, notice again that our critical value comes from the standard normal distribution, and the rest of this formula looks just like the one that we used for the standard deviation of a sampling distribution for sample proportions. And notice here that the p-bar, again, is the sample proportion, and that the n is underneath the square root. To find our confidence interval, we take our sample proportion and subtract, and then add the margin of error to get our two limits. Here are the steps that we'll go through. First, again, we want to verify that the requirements are satisfied. Then we find our point estimate, which is the sample proportion, p-bar. If this is given as a percentage, we have to convert it to decimal form. We find our critical value from the standard normal distribution, find our margin of error, and find our confidence limits. Again, we can write our confidence interval as an inequality or in interval form. And for proportions, we're going to round our confidence interval limits to 3 decimal places. Here's an example. A poll of 1,501 randomly selected adults showed that 70% of the respondents believe in global warming. We want to find a 95% confidence interval estimate of the proportion of U.S. adults who believe in global warming. First, we want to look at our requirements. This does qualify as a binomial experiment because there were only 2 outcomes, and we can assume that the trials were independent. And if we look at the sample data, there would have been at least 5 respondents who said they believed in global warming, and at least 5 who didn't. The point estimate for this example was already given in the problem. They gave it to us as a percentage, 70%. So all we need to do for our sample proportion is convert this to decimal form. So we have p-bar is equal to 0.70. We've already seen that for a 95% confidence level, our critical value of z turns out to be 1.96, and then we're going to use our formula for the margin of error. So we put in the 1.96 for the critical value and our sample proportion of 0.70 here and our sample size of 1,501 there. And this turns it out to be 0.023183. Now we want to find our 2 confidence interval limits. So we start again with our sample proportion of 0.70 and subtract our margin of error to get our lower confidence interval limit. Then we go with our sample proportion plus the margin of error to get our upper limit. We're going to round each of these to 3 decimal places, so we get our confidence interval goes from 0.676 to 0.723. We could also write this in percentage form. So it would go from 67.6% to 72.3%. And here's how we could summarize the results of this. 70% of United States adults believe that the Earth is getting warmer. That percentage is based on a Pew Research Center poll of 1,501 randomly selected adults in the United States. In theory, in 95% of such polls, the percentage should differ by no more than 2.3 percentage points in either direction from the percentage that would be found by interviewing all adults in the United States. Basically what we're doing here is we're giving the sample proportion as our estimate, and then here where it talks about varying by 2.3 percentage points, that's the margin of error. And notice here our confidence level was 95%. Now if you're looking at a poll that's already been done and analyzing it, here's some things to consider. The sample should be a simple random sample. and not an inappropriate type of sample such as a voluntary response sample. The confidence level should be provided and the sample size should be provided. Now, one thing to notice here is that the quality of the poll results depend on the sampling method and the size of the sample, but they don't depend on the size of the population usually. And again, there's a very common misconception that results like this are unreliable if the sample size is very small compared to the population size. And notice that in our formulas we don't use the population size anywhere, so it's usually not a factor in determining whether a poll is reliable or not. And here's how we would find an appropriate sample size if we were designing a poll or a survey. Again, if we can estimate what our sample proportion might be, we call this a planning value, and in our textbook it's denoted by P star. So here's the formula. We use a critical value that's tied to our confidence level, and then we use our planning value of P star in these two places, and in the denominator we have our margin of error squared. And again, since we're dealing with proportions here, the margin of error has to be in decimal form, as does our P star, our planning value. If we don't have a good estimate of our sample proportion, then we have to go with sort of a worst case scenario, which would be that our sample proportion was actually 1/2 or 0.50. So when we don't have an estimate of the sample proportion, or when we don't have a good one, then we use this formula. And this one just uses 0.5 for the P star. Here's an example. An eBay manager wants to determine the current percentage of U.S. adults who use the internet. If we're designing a survey, how many adults must we survey in order to be 95% confident that the sample percentage has an error of no more than 3 percentage points? We'll do this problem two different ways. First of all, we'll use results from a similar survey in 2008, which found that 73% of adults use the internet, and we'll use the 73% as a planning value. And then we'll do it another way, assuming that we don't have enough information to estimate a planning value. So the first way, we're using 73% as the planning value P star. We convert it to decimal form, so that's 0.73. We know from earlier examples that for a 95% confidence level, our critical value is 1.96. The margin of error we want is 3 percentage points, so we have to convert this to a decimal form. So E is going to be 0.03. Here's the formula that we're using since we have that planning value, and we're just going to plug all of our values into the formula. This turns out to be 841.3. Always with sample sizes, we want to round up to the next greatest integer, so we would round this up to 842. Now, if we don't assume that we have a good estimate for the sample proportion, we'll use the second formula. We still have our critical value of 1.96 and our margin of error of 0.03. Here's our formula, and if we plug those two values in, we get 1067.1. We would round this up to 1068. And notice again that we used what I called our worst case scenario here. That's going to give us the bigger sample size. And that's if we don't have any kind of estimate for our sample proportion. So this is the safest way to go. It gives us a bigger sample size than if we have an estimate for the sample proportion.